Okay. So welcome everyone to the first in our October TI-84 Wednesday webinar series. We're really happy to have Ron Lancaster, who's been a longtime advocate for coding with the TI-84, join us this evening to share what we know will be creative. If Ron's involved in it, it's going to be creative stuff. So really excited to learn alongside all of you guys. So thank you very much for doing this evening, Ron, and over to you.
Thank you, Tom. Much appreciated. You know, it's just so nice to see a number of names of people here and faces of people in some cases that I've known for a long time. And I would imagine, based on what I'm seeing here, there's a range there's definitely people who have been programming probably for longer than me. And there may be some others who are just starting as well. I have a Dropbox folder put together where I put some programs in there. There'll be a PowerPoint file and all of that. And so, if you have other questions, you can go back and look at things later, or you can contact me. And I'm, happy to help with some things. I thought that tonight, maybe in order so that we don't get kind of bogged down in, actually physically writing code, because we have an hour, roughly here. And we could spend 45 minutes kind of pressing the program key and scrolling over and grabbing code and doing all of that. I thought maybe what we could do is look at a little series of programs that I'm going to put forth here, and we can look at the code and see what we can learn from them, and also talk a little bit about where it could be used in the curriculum as well, and how we can make room for coding. If you want to actually take the program and put it on your handheld device, you can use TI Connects for that, or you can import it into the emulator software. As I go along, Tom is going to post the programs, and so you could do that if you like. But I'll also be showing the code up on the screen, and you may be content just kind of looking at the code and seeing what we can learn from it, and then putting it onto one of your devices afterwards. I'll leave that up to you.
Ron, I
Yep.
actually can't post it because your Dropbox is blocked. My computer won't allow it. I have the link in there. So I'm gonna, or if people kind of click on the Dropbox link, will they be able to get to the files, or do you not
Yeah,
want me
there's
sharing that?
no password.
Okay.
You do not need a Dropbox account.
Okay.
So yeah, they should be able to obtain them that way.
So Victoria, maybe you could be the file kind of dropper into the chat for us. Could you, since you got it open there? So if you see Ron reference a certain file, that'd be awesome. Thank you.
Oh, that's great. Yeah, thank you.
Okay.
Um, this feels a little bit odd every time I talk about coding, because some of you may know this, but I had dreams of becoming, a coder and doing something in the computer industry when I was in high school and early university. I had won a trip to the International Science Fair when I was in high school in grade 12. I designed a computer that played tic-tac-toe. This is a picture of the computer. It was all hardcore. I mean, it was all transistors, diodes, relays, and all of that. And that's where I thought my career was going to go. And I was so enthused about coding and all of this. But then it fell apart. In second year university, I got into an assembly language course at McMaster, and I was just, totally confused. I didn't know what was going on. And I just kind of walked away from computers and got into mathematics, and really did not come back to computers. So, it took a long time before I eventually came back. So it always feels weird to me when I think about my career and that huge long gap, where I could have been doing more coding if it weren't for that assembly language programming course. But that's the description that I gave Tom. And so, we're going to look at some mathematical problems, the idea of tinkering and playing. I think that, we probably all know the benefits for coding, from students doing coding. And really in Ontario, coding is part of the curriculum now from K to 12. So, it's kind of a given that we should be doing it in our classes. But anyway, that's what I had sent to Tom. Some of you might be wondering, or you might get questions about why code with the TI-8384, because I think we could make a good case that Python is much more powerful and much better, or other programs as well. So like, why the 8384? I think one of the key things for me is that it's all about constraints. You might want to Google this, creative constraints. There's been a lot written about this. People have done research on this. And one of the issues is that when you are constrained, you become more creative. If you have everything around you that you could possibly need, the creativity isn't the same. And people have studied this and found that this is true. These are a couple books that you might want to take a look at. Creativity from Constraints, and also A Beautiful Constraint, that get into these issues. Because really, when you code on the 8384, you are constrained. You don't have at your disposal all kinds of tools and commands and things that you can use. You have to get creative. Otherwise, you're not going to get anywhere. So I think that's for me, a plus in using a device like the 8384 and using TI Basic because of the constraints. I thought what I would do is begin with a program that it's a welcome program. And let's take a look at this. So this is a program for the TI-8384. Of course, you could create that easily in all kinds of other things. But doing this on the TI-8384 requires some ingenuity, some creativity in order to do this, because there isn't a command that says, oh, take a word and move it along a curve, and do it. You have to make that. What are some areas of the curriculum where you could see this being used? Maybe in the chat, you could just put in, a comment what could you be teaching where you might have students creating something like this. And Tom, you can keep an eye in the chat if you don't mind, if you see some things coming in here. So what might you be teaching?
Keeping my eye. Sine and cosine function, periodic function. So Victoria says sine and cosine function. Jemima, periodic function. Jiu, sinusoidal.
Oh, that's great. Anything else?
XY coordinates.
XY coordinates, very nice. Does it have to be on a sine curve? Right? Could it be on a line? Where it travels along a line or along a parabola, or could be any curve, couldn't it? So really, this could be done with anything. It does. I happen to use a sine curve for this, but because I wanted a welcome sign for all of you. I know it's a bad pun. But it could be anything, for this. So let's take a look at the code for this, because the code is something that, just come back here. Okay. You don't have to do this tonight, but this would be a really good program for you to take a look at, to learn about coding. In fact, this is a great way of doing it, is to look at other people's code, and see how was that created. If you look at the code, the first, 7, 8 lines is just, you're just kind of fixing up the calculator. So you can ignore that stuff. But you can see those text commands, that was putting in the text message that you saw. And a great exercise for your students, if you had a quadratic here or a sine curve or whatever, is to ask your students to figure out, why is this working? Like, what is really going on here? You can see that there's a variable t that's going from 0 to 200. Why is it 200? What would happen if you made it 100? So what you'll be able to do is, because you're going to have the program, change the 200 to 100, see what happens. Do you get half the sine curve? Like, what do you get, when you do that? And then you'll see that there's this I part, the integer part, because you're dealing with pixels. And so you're taking the integer part of a sine, and you'll see 20 sine 8y. So what would happen if you change the 20 to 40 to 30? What about the 8y? What do you get if you make that 4y or 10y or 2y? What happens when you do that? What happens if it's 8y plus 3? So, when you're teaching trig in this case, and you're looking at the transformations, this could be a really nice program for your students to use so that they could tinker here with, even without understanding the code, just go into the code, tinker with those things and see what happens, when you do that. But that middle part right there is the guts of the program. There are a couple do nothing loops. For Z, Z goes from 1 to 50, Z squared store in W. That's just slowing it down, so that it doesn't just, whip across the screen. It actually slows it down doing it. Are there any questions on this code? I'll move on to another program in a moment, but is there anything here that you're wondering about when you look at this? I'll give you a moment to either put something in the chat or just, speak up. If you don't right now, you can always email me later, and I'm happy to, help out. There is one question you might be wondering about, and it's, why did I do t store in y? So I took the variable t and I stored it in y. Like, what was the t about? And I'm going to be honest with you here, I don't remember. I've created a number of versions of programs like this with parabolas and sine curves and lines. And I was looking at a few of them today, some recent ones, some old ones, and I did that in every one of them. And it's like, well, why was I doing that? Like, because the loop could have been for y, from 0 to 200 with a 1. I don't know, I guess I must have thought I needed an xy because it kind of looks like math. But I'm not sure why I was using a t. So if you're wondering about that, I'm wondering too. The text color is something that's new. So that you'll see with the new TI-84, the color versions. So you can assign a text color to, the text. Wouldn't have been able to do that on the old 82, 83 models for that. Tom, do you see any questions in that one?
Yeah, so well, first off, thanks, Victoria, for posting the file. Dragana, I hope I'm pronouncing your name right. She noted it'd be nice to change color if it changes direction. This is an answer to your question before. And then Chris is wondering if there's a sleep command similar to Python instead of a for loop.
Great question. I'm just kind of getting into Python. I'm slow to get into Python, and I don't know where I've been because Python is amazing. And I'm not sure. Maybe there's someone here on, who will know. It seems to make sense that there would be, right? That, you'd have some command that would just stop. Again, that's where I think it's beautiful doing it with TI Basic, because you don't have a sleep command. So you have to, like, what am I going to do? Like, how am I going to make it sleep?
Paul is asking kind of why not 20 sine 8t?
Yes, good, Paul, a good question. I don't know why I was doing that with the variables. I mean, you could, right? There's no need to have x, y, t. Just use xt, yt, xy, but you don't need 3 of them. Good point.
And then Chris is asking kind of if there's kind of memory issues, at what point does storing all of those variables fill up the working memory of the calculator? Like, do you have to kind of be conscious of that?
No, not with this kind of thing here. Okay. It's not consuming a lot of RAM as it's doing this. So you'll be okay.
And Derek has a note. I like that you were using text command versus display command. Access the draw screen versus the home screen, giving you much more control over the text.
Very good. Yeah, and that's a great point. The output command won't work very well with this because the output gives you big letters and the text command gives you smaller letters. And it's really cool because, again, if you give your students this program, they can tinker with the coordinates of my text. What I have 1010. What happens if that was 50-50? What happens if it's 1,000? You'll get an error. Why do you get an error? Because it doesn't have that many pixels. So lots of kind of exploring here with the numbers in the program that go beyond just enjoying the welcome sign. There's actually some, mathematics for students to learn or to figure out. And the wait command, definitely not with the TI basic. So yeah, but there may be with Python. Yeah, I was going to say, wait, don't tell me in case anybody knows, but that's a show in NPR that you may or may not be familiar with.
So Stephanie says that the TI basic on the 84 Plus has a pause command. The 84 Plus CE has a wait
It does.
command.
That's fantastic.
Yeah.
The pause command will stop the program. And so, you're going to have that nice welcome coming across, but then it stops. And if you press the enter key, then it keeps going. I suppose you could be, like pressing the enter key, you'd have like 50 pauses in there, but it wouldn't be very workable. So good suggestion, with the pause. These are great comments, here, absolutely. Anyway, I hope that, maybe if you're not new to programming, or if you've done a lot of programming, that there'll still be something here that you can use. For the newbies, this might be a way to kind of get into programming and kind of see how things work. And for those of you that have done a lot of programming, maybe it's just something you can go use with your students. The whole idea of tinkering with the numbers in the program and having students explore. If it was a parabola, tinkering with the equation, what happens to the letters, it's on a wide parabola, a narrow parabola, upside down parabola. What do you get when you tinker? So that's the welcome program, and welcome to all of you. This next one right here, I think what I'll do as well is I'll just run this program. So here goes. This program was written decades ago by an amazing math teacher that I met named Tim Pettis. So I've gone to this conference, the Phillips Exeter Academy Conference. So I've been so fortunate. I've gone 31 years in a row, and I've just met so many people. But Tim Pettis, I met in my early years there, and he was doing all kinds of programming, just the coolest, neatest stuff. And this was a magic trick that he showed me. This is actually an old, it's not really a magic trick, but magicians use this a lot, on their business cards. So here goes. You all set? You're going to see a number coming up on the screen. And I'm going to ask you to add up the numbers. When you get your answer, stick it in the chat as soon as you get your sum. So you ready? So we'll have you add these up mentally. Here goes. Here's the first number. So in the chat, stick some answers in. Oh my goodness, I thought I was going to fool everybody here. What? 4,100, 4030, 4,100? No. I don't know how people are getting the 4030 or the 4,100. We'll have to look at this. So how about I type in the correct answer here? So we all know that it's 5,000. It's the wrong answer. The answer is 4,100. You want to see it again? Let's do it again. So here goes. You all set? Do you see why you were getting the 5,000? Right, the 4080 and the 20 and 5,000. Amazing, isn't it? But this is typical of the kind of stuff that Tim was doing. Tim Pettis. This was like way back if I put in 4100, it says good for you. Your answer is correct. And so we have that. Here is the code of that.
There is so I think some of the people that want to kind of do a lot like the code along with you. So Jay Wu, don't worry if you're not able to kind of do the code. I think a lot of this that Ron is doing is kind of showing and kind of the computational thinking behind it. Now, there was a question, how do I open the file? Which I think that is probably not a bad thing to show, Ron, just to so the file that Victoria sticks in the chat, when I download it, what do I do?
Okay, so here's a couple quick things. And by the way, I know that some of you may want to kind of code along, but if you just looked at for a moment at that add trick one, like it's 2 great big columns of code, and there'll be half an hour later that you'll have it in, and you could easily spend that time after the talk tonight and put that in. So how do you open it up on your computer? 2 methods. So one thing you could do is, if you have the emulator software, and I know this won't work for a couple of people with Chromebooks, but let's look at people who have the emulator software. So what you'll do.
There is actually a Chrome app that will allow you to do this now.
Oh, okay, good.
But it's only 10 people in Canada have it, so chances are slim that they're
here. Yep. So if you have the emulator software and you want to put the program into the emulator software, you're going to have to go on the far left, and there's 2 tabs. There's a picture of a little calculator. That gives us what we're looking at here. And right below it, this shows you everything that is on the calculator. That's all the files that live on the emulator software. And it is so sweet. You want to put a program there? Pick your program on your desktop or wherever your downloads folder is, and you're just going to take it and just drag it. You just drag it into that window, and you'll get a little message that'll come up saying, do you want to send? And in this case, I'm getting a message that says, do you want to replace the existing program with this new one? Turns out they're the same program. So I can click on send, and I'm not going to hurt anything. So that's one way of getting a program that you might find, say, online, or the programs you're going to get from me tonight. You can put them into your emulator software.
And then where do they go to actually run? Do they run the program from here on?
So we got to get away from seeing the guts of the calculator. So I'm going to go back to the emulator software, and I'm going to press the PRGM key right in the center of the calculator. And that's where the programs live. Now with your
so just a note to those of you that have the latest version to run, you need to update your software. That if you click on PRGM with the latest, you're going to get 2 things. It's going to ask, do you want it in TI Basic or do you want it in Python? So tonight we're going to do TI Basic.
Yes.
Okay.
Yeah. And actually, I have the latest software and I'm not getting it. I was finding that just so annoying because I wanted to concentrate on TI Basic.
Yeah.
So I just deleted Python off the thing. Okay. I just got rid of it.
So Python is just so you know, you can do that because Python is just an app.
Yeah, I can bring it back on.
Exactly.
Yeah. So that's where to live. And if some of you do want to code, tonight, that's what you want to spend your time on, and you're more than welcome to. Then you would scroll over to new, and you'd press new, and then it'll already be in alpha mode, and you can put in a name. Only 8 characters. It's an old DOS thing. So you're allowed up to 8 characters. No spaces, no decimal points in the middle. Can't begin with a number. It's all this DOS kind of structure. But that's what you would do. The thing I'm just a little bit concerned about is if I leave the code up, I need to put up other things as well for people. And I think the screen's you're just going to get a little bit busy here if I have the code up for some people who want to spend the whole time coding one program and the other stuff. So I think I hope you won't mind that I'm not going to spend a lot of time on, entering in the code. If that's what you really showed up for, email me and I will Zoom with you and we will, do some coding from scratch. And I'll be very happy to do that. So that's where you'll find the programs. And then you can scroll down to whichever one you would like. And you'll, enter them in. So for example, there's Mona Lisa. So I'll choose Mona Lisa and run Mona Lisa. And what this program does is it draws a picture of Mona Lisa. Some of you, if you've been coding for a long time, some of you might, want to think about how that was done. Like how was that accomplished? To have a program doing this. So maybe down near the end, I can tell you more about that. But that's an insane program that's drawing a picture that way. Tom, is that okay? The issue of getting this? And the second method, so here's another method. There is TI Connects that is remarkable. This is absolutely a must-have, and it's available for free. So here's TI Connects. And this is so beautiful because you can do your coding here. So you can open up an environment where you can code and work with it. You might like the interface a little bit better here than doing it on the handheld. But more importantly, you can actually click on Open Program, and then I can open up Add Trick. So the one we just looked at, Tim Pettis's program, and boom, there's the code. So it'll open right up. You can copy and paste pieces of code that you might like to use somewhere else. You can just go in and press enter and put in new lines. You can correct stuff. It's not like Python where you can, press Command R, to compile the program and then have it run. You need to have to save the program, put it into the calculator, the software, and then run it there. Because TI Connects doesn't run the program. It just allows you to view code and to type in new code.
So there is still a question from Kiera about how do I run files that are .8xp? So that's that process that Ron showed Kiera. So if you pull them into that over way on the far left side in the Smart View software, you select that lower icon. So way over on the left there, click on that, and then find the file on your computer, and then you just drag and drop it into that space. Then you go back to the top left icon, and you click on the program key, select TI Basic in our case, and then that program will live somewhere in that list of programs. And then when you click on it with EXEC, that's execute, so it's going to run the program from there.
Beautiful. What I'll do, I'm just so thrilled that there are people who are, wondering about these things, and that after tonight, I'll make a little short video kind of going through those two things, how to get programs onto your device or onto the software. And I'll make a little program, like you'll actually see me do one from scratch, so that you'll see kind of, what do you press, what do you do, and that kind of thing. For those of you that have been programming for a long time, you don't need that, but there's other people tonight that probably would love to have that. So Tom, I'll put a video together like that, and I'll send you the link. Can you then email everybody?
Yeah, we can even include it in, so when I put the recording of this session, kind of all the kind of support stuff we can throw in there too.
Sure, yeah, absolutely. And I have a Dropbox folder put together too. I'll put it in there as well.
So
So
just a quick question to Kiara. Kiara, do you have the SmartView software? Is that the issue, or you have the TI Inspire software and you're trying to open the .8 XP? Because if you need to have the SmartView software. And for those of you that don't have the SmartView software, just go to the email that I sent earlier and the link will be there for you to download it. Okay.
yeah, and the .8xp won't work in Inspire. So again, the title tonight was, TI basic coding on the 8384. And I hope you don't mind that, like, I'm not addressing Inspire. I just thought, like, in an hour, like, how are we going to get anything done if we got both platforms kind of going at the same time? But yeah, so these are just for the 8384 that that you'll have here. So that's and this mental math program that Tim Pettis created. When you look at the code, and you'll have access to it because you have the programs. It's fairly long what Tim did, but there's one really new thing that may be new to some of you, and it's the ability to have a menu. You remember how it said, do you want to try again? Yes, no, quit. That's in the middle here. So there's a menu command when you're programming. And the way the menu command works is you put some text in quotation marks. That's, that's what comes up in the screen. And then you could have like 8 different choices, for this. So, try again, that's label 1. Quit, label 3. So, and so that's what might be new to some of you. And if you're new to programming, I would definitely come back and look at this code right here, because the menus are actually very handy. You might have your students actually design a little kind of multiple choice, true false quiz on some content. So instead of this cute little add trick, up in the screen would come a math question, true or false. And, the user of it would type in, a 1 for true or a 2 for false or whatever you want. And then, you could just basically copy Tim's program, but do it instead of having his context, use the context of some little quiz that your students would prepare. So, maybe they have to prepare 4 quiz questions, for the class, and base it on Tim's coding here. So there, I think the bigger issue there is the students' quiz questions. What questions did the students pick? And if it's a multiple choice question, which 4 choices did they pick? Why did they pick those choices? For that. But Tim's program here, it's a lot of output commands. At the top of the screen, output 1, 1, first row, first column. It just says, what is your answer? And then there's some display commands that just move the cursor down. Input X, it's where you put in your answer. Remember, I put in 5,000. And if somebody puts in 4,100, it routes somewhere in the program. If you put in 5,000, it routes somewhere else. So it's just a lot of routing here. Good programmers tend not to like to use labels. I don't consider myself a good programmer, but if some of you are really strong programmers, you might look at some of the labels and think it's kind of old school. And I've just found with students that I just found it easier to kind of get them doing some coding when I use labels, because it, you can do it other ways, but sometimes it just makes it more complicated when you just want somebody to do a bit of basic coding and nothing more. Are there any questions on Tim Pettis's coding here? Magicians have used this for many, many years, where they have a little cardboard sleeve with a little window on it. And there's a piece of paper inside that you slide up and down. And it's like a business card. So you slide it constantly down and you see one number at a time. So you give it to people and say, add up these numbers, show them a number, push it down, show a number, push it down, show a number. And, they get like 6,000 when the answer is really 5,100, or, whatever. So Tim had seen that somewhere. I think he had a background in magic, where he'd seen that. Tom, are there any questions on this one?
You're muted, Tom.
Talking to myself again, sorry. Derek has a comment that he really likes the go-to command to a label. He uses it a lot, gets them out of tight spots.
Absolutely.
And then Anthony says, I saw this trick on TikTok. So that's kind of cool. That'd be a neat link to throw in there too, Anthony.
Absolutely. Nice that it's current.
And Anthony, Derek noticed that it is clear home versus clear draw. So clear home screen versus the draw screen.
Yes, the clear home takes big text away. So, the output command puts in big text, and you need the clear home. Those little letters you saw with the welcome sign, those are that's done with pixels. And so you need the clear draw to get rid of those. Well done. This also will be a great program, even if you're kind of moderate abilities with programming. There may still be some new things in Tim's program. Tim was this guy was just off the wall. He had another one where it asked you to pick. There was something about putting an odd number of sugar cubes into a coffee cup. So there was an actual picture of a coffee cup and sugar cubes, and you were supposed to put in an odd number of something like that. And it turned out the answer was like 13 sugar cubes, because that's an odd number to put in. It's a weird number to put in. This stuff was just off the wall. So let's take a look at one for the very first program that I learned to see. And I learned so much from this program. And I think if you're new to programming, you will too. And if you've done some programming, there might be something new here. So back in 1994, I was really fortunate to be up in the building of One Times Square. So I was watching the ball drop. It turns out my spouse is from New York City, and her best friend was Thomas Starr, and her family owned Artcraft Strauss. And, they created the Great White Way in Times Square, all of the massive neon signs, and her grandfather started the ball drop like 100 years ago. So they did the ball drop. And so Tom invited us up onto the roof. And so we watched this. And so I wrote a program with great help. Actually, I didn't write it. Chris Bruggenson did. That really, I learned so much from it. So let me show you the program. So this is called New Year's Eve, the name of this program. And we'll just scroll up here and grab this. Very simple program. So it asks you for a number. So I'm going to type in 500. There's a very simple diagram of the building at One Times Square with the pole. I entered in 500. And what your students can do is use their iPhone or their Samsung phone, whatever phone they've got, Android phone, or a stopwatch. Old school watching a stopwatch. We're using a stopwatch. And time how long it takes for the ball to come down. So here goes. I entered in 500. Here goes. So the ball is coming down. This one is painfully slow. So I'm going to just clear that and just put in another number here where it'll be faster. So what my students were doing is running this program on New Year's Eve or whenever during the holidays. And they were entering numbers in, trying to make it take exactly 10 seconds. So that was the goal. to come up with a way of having it take exactly 10 seconds. Because if you put in that initial number, when you put it in, it changes the speed. So if I put in 5, it's like, it's just boom, it just happens. So here's the code. Lots to learn from this code. So this was done by Chris Bruggenson, who some of you may have met him. Also met this guy from the Exeter conference years ago. He was Mr. CBL and Mr. Programmer. This guy was unbelievable. And I told him I'd been working on this program, for a while. I couldn't get anywhere. And Chris sat with me, spent a lot of time working on this, and eventually came up with this code. I was able to modify it a little bit, but really this is Chris's code. And this will be a really good one for you to learn how to do an animation, where you have something moving along the screen. This is so much easier if you use other things, but that's not the point. This is about being constrained, where you've only got so many tools to use. On the left-hand side, the upper part is just housekeeping. It's just, getting the calculator set up and getting the windows set up. The lower left, that's the buildings. So it's the building with the flagpole. They're just line commands. Guts of the program, it begins in the upper right corner. There's a variable h, starts off at 62, drops down to 21, goes down in a weird increment, minus 0.55. I remember asking Chris, why the heck are you using minus 0.55? And Chris said, because it works. He was tinkering. He was trying to get the ball moving down and then rubbing out part of the ball, because that's how this works. The ball starts, put in new points and rub out the points up here. Move it down, rub out points, move it down, rub out points. You're basically just erasing part of the ball as it moves down. But this will be a really good one for you to look at, have your students look at, and then ask them to create some other effect, where something moves along the screen. It might be a circle, it might be a square, might be a line segment where it moves across. This is all about just turning on points and erasing points. After tonight, what I'd suggest you do is just make h equals 62 and just plug in h equals 62 and see what you get. Look at what is being made when you do that. And then make h equals 61, and kind of see what changes. And you'll get the idea that it's just this ball. It's not really a ball because you can't make it curved with the pixels, but it looks that way. And then it just moves down. I thought it was just brilliant what Chris had done. And there's a sleep, pause, whatever you want to call it, but that for a equals 1 to t. As you change t, it's slowing it down or speeding it up, depending on the size of t. Are there any questions on this one? I think a key message here for you is the programming becomes really engaging for kids if there's kind of some context to this. If there's something kind of in the background that is pretty interesting. It might not be this for you. You might care less about the dropping of the ball, but it might be something else that you could, do where you would, have your students create a program around like this, with some animation or something happening. Tom, are there any questions that have come in about this particular one?
No, I think everyone's riveted looking at that. And I like the this approach rather than let's all build code together. This idea of reading code and analyzing it and thinking about it is really an interesting approach. Kind of, I think that maybe a nicer starting point for a lot of people that are new to coding.
Tom, that's That's nice of you to notice that. You know, you're seeing the teacher side of me here, that over the years when I tried to get students doing some coding, I just kind of gradually evolved to this method, you know, of giving them some code to look at, things that they could tinker with, you know, and change and play with, and getting into coding that way. Because I tried other methods of let's all code together, and, you know, just a total disaster. I remember it was 1992 at the Exeter conference, I taught a week-long course in coding for teachers. And, you know, I was excited doing this, but it was like a disaster because like we were just so enmeshed and, you know, press the program key, scroll over, and then somebody saying, hold on a sec, I had my head down. What did you just press? Oh, I pressed the program key and I'm doing this. And then it was just like, what a disaster, you know, trying to make it work. So Tom, I think this is maybe a better approach here of doing this. So let's take a look at another program then. So let's do the heartbeat program. Let's see here. I called this one Flash, but it, you know, you could call it heartbeat, although you can't fit that in with that many characters. Okay. So it's asking you for a number here. And if you want to time this, so if you have your phone handy, you could time this and see what happens. So I'm going to type in 1,000. What you're going to see is 10 flashes of a heart. And if you've got your phone ready, find out how long it takes between seeing a 1 in the upper left corner and a 10. You know, the 1 is the first heart, the 10 is the last heart. So between the time you see a 1 and a 10, how long does that take? So here goes. Ready? So in the chat, if you did this, put in the time, you know, that you got on your phone. .5 seconds. Interesting question with your class. Everybody's watching this on the screen. Take the times and look at them. Statistically, you're not going to get anybody saying 1 second. You're not going to get anybody saying 100 seconds. Bell curve, right? There's going to be a time that kind of, you know, most people are kind of gravitating towards. So we have a 14.5 there. And there may be just one person who actually, you know, put in the time. So here's the deal. I want the 10 flashes to take a minute or 30 seconds or 20 seconds or 10 seconds, whatever. So I specify how long the 10 flashes are to take. And what your students have to figure out is what number do you put in? So I'll do another number here. So this time I'll type in, say, 30. So if you want to time this, here goes. That was impossible, wasn't it? Not a good idea. So maybe I need to put in 100. Now, it's ridiculous. Maybe 500. Anybody have the time for that one, just so that we have a bit of data? 8.7. So you have 2 data points now. We've got 8.7, 8.5, 8.8. So you have 2 data points. So can you use your data points to find a model, that relates the number, the number you're putting in is the independent variable. Call that X or T or whatever you want to call it. How long it takes is the dependent variable. And in the Dropbox folder, I'll have a file set up for you, a worksheet for your students. And it's going to look like this. So heartbeats on the TI-84. Have your students put in two numbers. I've suggested 1,000, 1,500, whatever. This is really scaffolded. You'll see here that I've just everything's laid out. Put in these numbers, find the equation, do this, do that, and go through it. That's one style of writing the questions. I think it depends on the class, right? I think we're moving in the direction where we don't want to do that all the time. So I think I would prefer to have a mix of sometimes having it very descriptive that way, but also having questions where you just ask students to find a mathematical model and don't tell them that it's a straight line. Don't tell them what numbers to plug in. Just give them the program. You want it to take a minute, go for it. But, some kids aren't at that stage where they can work independently that way, and they perhaps need the version of the handout that I just showed you. Kids are at different stages, as we know, but we're all trying to move away from telling too much. That handout is really full of a lot of telling, but it may be suitable for some students. The code for this flash, this will be another one that will be really good. I've tried to pick a variety of programs here. This has something new, and this idea of storing a picture, where you can generate a picture and store it and have it come up in the screen, go away, come up, go away, come up, go away. And you'll see there's some clear draw commands there. And there's also a shade command as well, that you'll see there that will be new. The shade command is really cool. So you can take two functions and shade them. You can specify, the domain. I want to shade these two functions from x equals 3 to x equals 7. So you could alter that if you'd like. Any questions on the code here? So is there anything that you're wondering about with this one? You'll see the sleep things again, the whatever you want to call those, the do nothing, loops where it's just kind of spinning its wheels. And that all depends on the number that, is put in, X. Tom, anything there at all about the coding?
Not seeing anything in the chat.
Okay,
and
good.
We're a small enough group too that if anyone has any questions or comments, feel free to unmute your mic and
yeah,
and ask
absolutely.
too. Yeah.
Yep. So, if there's nothing tonight, there might be some later, and you're more than welcome to reach out to me. And I, the programs that you've seen so far were ones, except for Chris's, that I created, and I can speak to them and tell you a little bit more if you have some questions.
Anthony has a question. Does it execute faster on your emulator than it does on the handheld?
What a great question, Anthony. Absolutely, yes. Yes. Yep.
And Anthony, the inverse is true for Inspire. It runs slower on the Inspire emulator than it does on the Inspire handheld, which is an interesting inversion.
Anthony, I've used variations of that assignment over the years with students, and on the handheld, there's no way that I would have put in those suggested numbers of 1,000 and 1,500. It'd be an eternity, doing that. Yeah, this program I've used for a long time. The first time that I used this, I was teaching in an all-girls school in Oakville. And I'll never forget my calculus class giggling away because they entered in like 1 million, and the heart just stayed in the screen. It wasn't beating anymore. And they were saying, this is how I feel in this relationship I'm in with this guy. And they were, making all these, comments. It was just, and others were putting in like 0.5 and it was boom, 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 because they just met somebody. But But it's an interesting program. Again, there's a context here, to it. It isn't just a program to kind of do something inane. So let's take a look at one or two more programs here. Tom, how are we doing for time? Are we constrained by 8 o'clock?
I mean, we've been very flexible kind of in these. So we say it's an hour, but we're not, like, if you're kind of on a roll and we're in a state of flow kind of thing, we're not going to break that kind of thing.
Okay,
Right?
I have a couple more programs and then we can call it a night. By the way, I have a suggestion for all of you. This movie, if you've never seen it, stream it. Find some way of watching it. I saw this at the Toronto National Film Festival a number of years ago. It's a very sweet film. It was a love story to Halifax. It was about a young woman who was struggling to kind of find herself, drifting around, and there's just a lot of things that I saw in this woman in the show, in the film, that reminded me of some students. But it would be a great film for you to watch. It's a Canadian film. And Paul, you've got a question?
Yeah, thanks, Ron. And to this point, and I think Brianne and Cindy, maybe this is along the same lines as what they put in the chat. The strategy of decoding the code to figure out what it's doing, I think I'm also kind of looking at when you were displaying the code and trying to figure out, okay, what's that line doing? What's that statement doing? And I wonder, do you have a strategy, like when you display code, to help students kind of get past and getting hung up on these? It's almost like saying, looking at any language, whether you're talking about coding or just any language, and understanding what that word is intending or meaning. So do you have a strategy to address that?
I think, Paul, a great question. I think one great strategy is to try and make sure that it isn't the first thing you do isn't a program that's 1,000 lines long. So use things that are fairly simple but engaging. So it's something that kind of draws people in. If it's just something that does the Pythagorean theorem, it doesn't have that engagement kind of factor like maybe some of these do. But using fairly short programs, and what I've done is a lot of the busy housekeeping work and stuff in there, I've given them explanations of what that does so that they don't have to worry about those things. And it's just part of the code that we're looking at, that we're learning from. So use short code and don't have them kind of trying to figure out the whole thing. It's just really frustrating. Take a chunk of it and concentrate on that. And especially if that chunk is something that you can tinker with, like that sine one at the beginning, changing the 20 to 30 to 40 to 50 and what happens when you do that. And you start to see the role that it's playing.
Okay.
Does that help?
Yeah, no, that's a good strat. Yeah, great.
Okay. Yeah, thank you. So that's the film, Heartbeat, and lovely film to see. So the hailstone sequence. This is actually a wonderful activity for lots of your students. So many of you have probably seen this sequence before. So you start with a number, positive integer. Start with 7. If you have an odd number, multiply by 3 and add 1. If you have an even number, divide by 2. So you can start with whatever positive integer you want. This is a really famous sequence. And what mathematicians have found is that eventually, no matter what number you start with, you always end up with a 1. Nobody knows if it happens for every single number, but every number tested so far up into the billions does go to 1. It's a very curious sequence. So if you have an odd number, multiply by 3 and add 1. If you have an even number, divide by 2. So far, so good. Let's take a look at a program for the hailstone sequence. So it's number 7. What this program does is it allows you to put in a starting number, say 7, and it tells you how many steps it took to get to 1. So, and it also tells you the maximum number reached. So if you look back at my PowerPoint file here, I started with 7. You could count how many steps it took to get to the 1. Don't include your starting number. And the maximum number was 52. So what this program will allow your students to do is just to tinker a little bit and just, what happens when you put in different numbers? What about 856? Well, that took a long time. It took 103 steps to get to 1. So there's a lot of nice just tinkering with the numbers and getting to know, the sequence. And you can put in like a really big number, thinking, oh my goodness, this is going to take a long time. Or will he ever get a 1? That was 105 steps. So here's some mathematics for you with this sequence. This is the code. There's going to be some really nice things for you to look at here. Ignore everything on the left side. It's all just housekeeping. I shouldn't say ignore everything. There's some things in here where the coding checks. Did the user put in a number that was negative? Did they put in a decimal? And if you look at the coding around that, with Paul's question, you could have students just zero in on just that part. So, I shouldn't say ignore everything on the left-hand side because there's important stuff there. So, for example, if n is greater than 9999999, so look at the code centered around that and what's going on. What about the fractional part of n, left-hand side down near the middle? What's that about? What's going on there? And just seeing how, that's checking if somebody entered in a negative number or a fraction. The other thing you could zero in on is how in the world does this program know if you got an even number or an odd number? Where is it? Where does it check? And how does it check? That's a really good mathematical, exploration here. And you'll see on the right side, about a third of the way down, if the fractional part of x divided by 2 is 0, you got an even number. Take 6 divided by 2 and it's 3. Fractional part is 0. So that's how it's determining whether it's even or odd. And then it does the calculation. So there's like chunks of this code that your students could, look at and experiment. You could ask students, what about a variation of the hailstone sequence where you multiply by 5 and add 1? What code would you change? And what happens when you do that? Do you always end up with 1? So lots of things with the code here. But here's some math questions for you. So I'm thinking of a hailstone sequence. I started with a number, and the second term was 27. What did I start with? What number did I begin with to get 27? Well, what do you think? What number would you start with? Call it X, so that the second term is 27.
So Paul and Anthony are saying 54.
Oh, cool.
And I'm not sure. Is it Donna? I'm assuming that your first name's Donna. Is that right?
Beautiful. So yeah, absolutely. It's 54.
Yeah.
What they just did is they solved a linear equation that a middle school student could do or a grade 9 student. They solved X divided by 2 equals 27. Right? We're going backwards. So you start with X. and you get 27. So, okay, so what about 10? So if I have the second term of 10, what's my first term? It's kind of obvious, isn't it?
Well, we've got some different ones. So 3 or 20. And then some people are
No.
saying 3, some people are saying 20 or 9.
Ooh. So if it's 9, 9 is an odd number. Multiply by 3 and add 1, and you get 28, not 10. So it's definitely not 9. Is it 20? 20 is an even number. Divide by 2. Get 10. 3 is an odd number. Multiply by 3 and add 1, and you get 10. So what you're doing right now is you're solving two equations. X divided by 2 is 10, and 3x plus 1 equals 10. And it happens that the number 10 has solutions for both of those. So there's two different numbers you could start with that both lead to 10. Beautiful, isn't it? It's not the case for 27. If you do 3x plus 1 equals 27, you don't get a positive integer. So the going backwards, I find, is much more interesting than going forward. The program is kind of neat. It'll give your students a chance to kind of look at a couple little pieces of the code. But they're going backwards. And can you write a program to go backwards? So can you pick a number and say that that number is the fifth term of the sequence? What was the fourth? What was the third? What was the second? What was the first? That's your homework for tonight. Can you develop a program? What the program's going to have to do is when you stick your number in, it's going to have to solve both the equations. 3x plus 1 equals the number you put in. Is it a positive integer? How do you know? And x divided by 2 equals the number. There'll always be that one going backwards, right? You can always double the number, and go back. This would be a nice program for you to work on. And I have something for the walls of your classroom that is just gorgeous. Look at that. Isn't that amazing? That's where you start with the number 1 and you go backwards. And you get all these numbers that have two paths. And it goes out, 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 out. It's really beautiful. You could use sticky notes in your classroom to make this, put it up in the hallway, and design something like this. And the rings here, each ring, what the numbers have in common is that they all take the same number of steps. So all the numbers on the outer ring all take the same number of steps to get to 1. I think you'll love doing this with your students. Index cards, sticky notes, something, putting that up. If you visit that website, you'll actually see it happen before your eyes. It starts with the number and then it just comes out. It's beautiful. So that's the hailstone sequence and that you can work on. By the way, it's also called the Collatz conjecture. It's an unsolved problem. Nobody knows if every number leads to 1. And this is a comic from that kind of says it all. You keep working on this, eventually you have no friends, So anyway, I won't go over these with you tonight because we'll do a wrap in a moment here. This is a really old program. I remember seeing this, I'm pretty sure, in the mathematics teacher in the reader's reflection department. And this was written by a high school student. And today it's very much in vogue. Mary Barras up in Ottawa has done a lot of this where, her students create artwork, using Desmos or using Inspire. This student was, this program, I would have come across this math teacher probably 1995, 96, somewhere around that time. But the program will be in the Dropbox folder. And this will be a nice one for you to see. It's very simple. It's just got some housekeeping at the beginning and then just a bunch of shade commands. The deeper thing is how the student made it. You know, how did they choose these quadratics? It's all quadratics, you know, the whole thing. There'll also be a Mickey Mouse program also done by a student. This looks really complicated, but it's just a bunch of shade commands. It's all circles. It draws Mickey Mouse just with circles. Maybe before we quit, I'll run one of these tonight. But the programs will be there, the coding is there, and you can have your students look at them. The Instar, Substar, these are beautiful programs as well. They create a geometrical image on your screen, so you should take a look at that one. This one is insane. You know these stereograms where you look at something and you see it? Well, Neil Zabel, who's now retired, he's retired 2 years ago, taught at Deerfield Academy in Massachusetts. Another guy that I met from Exeter, Niels was doing stuff with programming decades ago that was just off the scale. And this is a program that he did that generates one of these stereograms that you stare at. And there's an image there. Stunning stuff. So maybe for some of your students, they might really enjoy this one. And they can take a look at the code and, you know, see if they can unravel it and figure out, you know, what in the world he was doing. I'll maybe run one or two of those programs before we quit here. But I've got a Dropbox folder for you. Just go to tinyurl.com and then just coding and math. That's easy to remember. All lowercase letters, coding and math. And if you have your phone with you, you can point it at the QR code. I spent more time than I'm going to tell you trying to get that program, instead of drawing Mona Lisa, to draw the QR code. And oh my God, that Mona Lisa, that program that created the Mona Lisa, it's like from 1993 or 4 and an 82. And I'm not even sure what I was doing. I just thought, you know, so anyway, I'm still working on trying to generate that image because that'd be kind of cool. You know, you want the QR code here, you run this program. And have you got the link? So just before we stop, here is a couple quick programs for you. Batman, probably many of you have seen this before. It's been a kind of a standard program that people often see. I think that this student did the most amazing job, you know, with creating an image of Batman using just quadratics. The circle star, a lot of great trigonometry in this and geometry to create those shapes. So a lot of line commands, but with transformations. So it's just beautiful. The Instar program, also very beautiful. It looks kind of fractal-like or something, you know. But you know, all these programs will be in the Dropbox folder with the coding for you as well. This again is a student who used circles, pieces of circles to create a beautiful image of Mickey Mouse. It's lovely. And I'll just see if there's anything else here. The stereogram, I need to contact Niels about running this because, well, or else I'll try and do it. This was originally designed for an 82, and I'm trying to kind of redo the program so that it takes advantage of the whole screen. You know, you've got more pixels now, but this is generating that stereogram that Niels created. So I'll stop here. Are there any quick questions right now that we can take a look at? I think just in summary, try to have a context for the programs, embedding them within the math you're teaching so that it isn't an extra. You know, otherwise we'll never do it. The curriculum, many teachers have trouble getting through the curriculum anyway. So I think you have to embed it within, what you're doing, and maybe also maybe be less linear. We are kind of linear, and by design, we have to have some linearity in what we teach, but maybe we're excessively linear. The way we're going through things, trying to, grab some content and do it together. And
There
I
is
mean,
a
it's funny that,
question. So
yeah,
Brianna's saying our school only has TI 83s. And I love that you're sharing that, Brianna, because I think the motivation behind this month's themed Wednesday webinars is really that as teachers, like you have to use what you have, right? And build off of it. So if 83s is what you have, what can you do with them? That was kind of the motivation behind this month's. But Ron for sure can answer this because he's been doing this with every iteration of the TI 80 something since the TI 82s, I think. So
yeah, the 81, yeah, and even
81.
the TI 80, which
Yeah.
probably a number of you may not have ever seen. The TI 80, they sold a lot of those in Quebec.
Yeah.
So these programs, I did take some time today looking through the coding. They should all work on the TI-83. So I don't think that there's anything in here that won't work in the 83. Brianna, if something happens where you get them onto those devices and you get an error, just write to me. And I'll look at it and I might quickly say, Brianna, I'm really sorry. There's a command I forgot about, not going to work. So maybe I can find a workaround, or you or your students can, to do what you want to do. But I think they should be fine on the 83. If any of you are still using any 82s, there's some stuff on quite a few of these programs. Probably half of them, you'll run into some problems. The 83, you should be fine.
I don't think there's anyone that old on this call. We're old here, kind of, Ron. So when you start
Yes,
talking
I mean,
82s, we're dating ourselves here.
I know, I feel like I am here, that I got this ancient TID2 in my hands here, but yeah.
So
I don't
as we
have
wrap up, I just wanted to thank, we are kind of like some people kind of have dropped off, and before kind of we lose any more folks, I just wanted to thank Ron so much. Like there's all kinds of comments here, Ron, that like you're such a wonderful presenter, your soothing voice, that you should be kind of having a podcast or something for sure. But besides that, it's just the creativity. So anyone that follows the NCTM journals and stuff, it's not just coding. Like there's so many, this whole idea of being more creative and innovative and engaging. So Ron's always been a real champion to that. So it's wonderful that coding is in the curriculum now. And that like Ron has been kind of trying to get people to pay attention to coding for so long, right? And I think it's hopefully going to come to life in a lot of your classes. Now, to those of you that are worried about, oh my God, like I should have read some manuals and then I could have followed Ron. We're not going to become Ron overnight or even by the end of this month. So I think our journey to becoming kind of Ron-like is our goal. And next week, we are going to be building something from scratch. So we're going to have Stephanie and Victoria leading you through FizzBuzz. And we're going to build something from scratch there. So actually having you code. And it doesn't matter if you have a TI 82, an 83, an 83 plus, an 84, whatever kind of thing. Like you can do that from scratch next week, which will feel very different. So it'll be interesting to contrast that experience and think about how you want to start coding, learning to code for yourself, how you want to start engaging your students and learning about coding. So just some really wonderful, wonderful things to think about there. So a huge thank you. I'm going to stop the recording now. And let me just, there we go. I've got
and
that.
I just